Good morning, madam. This is our case study, water supply and wastewater engineering. We have, uh, firstly, I will introduce you. First is Valentine Tan. Second is Romario and Ajirap. Third is me, Demir Dayan Agodan. And lastly, Kabul Tingom Anak Kibinjot. So, we are gonna uh, present about our case study.
Topic 4. Storage reservoirs are essential for water conservation, irrigation, municipal water supply, and industrial applications. The selection of suitable materials are significant for their construction. Location: Batu Kitang Water Treatment Plant. Determine the issues that related with the storage reservoir of the study area. Number 1. Water demand. The increasing population and urban development in Kuching have led to higher water. 2. Non-revenue water. NRW. A significant portion of water is lost due to leakage, pipe bursts, and other inefficiencies in the distribution system. 3. Saline intrusions. The Sarawak River, which supplies raw water to the plant, is vulnerable to saline intrusions, especially during dry seasons. That affects the quality of water stored in the reservoir. 4. Aging infrastructure. Some parts of the plant and its reservoir system require upgrades to meet modern standards and ensure reliable water supply. 5. Pollution. The catchment area faces pollution from untreated wastewater which can impact the quality of raw water entering the reservoir.
For question 2, explain the factor of the selected material for the storage reservoir of the study area. First one is durability. Materials must withstand environmental conditions such as humidity, rainfall, and potential flooding. Concrete and reinforced steel are commonly chosen for their long-term resilience. Second one is water quality preservation. The material should not leach harmful substances into the stored water. Non-toxic and chemically stable materials are preferred to maintain water quality. Third one is cost effectiveness. Budget constraints often influence the choice of materials. Locally available materials can reduce transportation costs and overall expenses. The fourth one is structural integrity. The reservoir must be able to handle the pressure of stored water and external forces like soil movement. High-strength material like reinforced concrete are ideal for this purpose. The last one is environmental impact. It is sustainable and eco-friendly. Materials are increasingly prioritized to minimize the environmental footprint of construction.
Several components are essential components in sewer system during system ensuring efficient flow, maintenance, and treatment of water wastewater. Select one of the group topic. First, manhole. B is pond. C is aerators. So this is the question. For first one, of the several type of above by giving suitable case number or study area. So manholes are invisible components of solar system offering access for maintenance, inspection, and repair of underground pipelines. They play a crucial role in ventilating solar system, preventing the buildup and hazardous gases and ensuring smooth wastewater flow. Manholes are strategically placed at junction, bends, or changes in gradient to support the sewer line and facilitate transition. They are designed and secure covers to ensure public safety and prevent unauthorized access depending On the depth and environment, holes can be shallow, normal, or deep, and are constructed using durable materials like precast concrete, reinforced concrete, or eco-friendly options such as fiberglass and plastic. Their adaptability and functionality make them essential for urban infrastructure and efficient wastewater management.
2. Explain the challenges of the sewer in the study area. The sewer system in Kuching Sarawak faces several critical challenges that affect its efficiency and sustainability. One of the primary issues is the aging infrastructure. We struggle to accommodate that increasing wastewater load brought on by urban development and population growth. Infiltration of stormwater and untreated wastewater further exacerbates the strain on the system, leading to overflow and environmental pollution. Limited coverage is another concern, as certain areas, especially those experiencing rapid development, lack proper connection to the centralized sewer network. Moreover, the proximity of Kuching to the Sarawak River makes the system susceptible to saline intrusions, particularly during dry spells, which complicates wastewater treatment processes. Financial constraints pose a significant hurdle to the expansion and maintenance of the sewer system, delaying crucial upgrades and leaving undeserved areas without adequate infrastructure. Adding to these challenges is the lack of public awareness regarding proper sewer usage, which often leads to misuse and blockages.
The activated sludge process is a vital method in biological sewer treatment relying on microorganisms to break down organic pollutant in wastewater. It began in an aeration tank where wastewater is mixed with active sludge in suspension of microorganisms and air is introduced to provide dissolved oxygen. The microorganisms consume organic matter through aerobic respiration, reducing pollutant and biologically stabilizing the wastewater. After the aeration phase, the mixture flows into a secondary clarifier where gravity allows the active sludge and solid to settle at the bottom, leaving clarified water on top. This water is either discharged or undergoes further treatment depending on regulation standard to maintain microbial efficiency. A portion of a settled sludge, known as return activated sludge (RS), is recycled back to the aeration tank while the excess sludge is removed for treatment or disposal. In summary, this the activated sludge process is an efficient sewer treatment method that combines biological and physical principles to reduce pollution, stabilize wastewater, and produce cleaner influence, addressing environmental and public health concern actively, effectively. The activated sludge process is a crucial biological method used in wastewater treatment, but it carries several potential risks that need to be managed carefully. One key concern is the health hazard associated with the process. Works and nearby communities may be exposed to biological aerosol, pathogen, and toxic gases such as methane and hydrogen sulfide during aerosol. Improper disposal of waste sludge (WAS) can lead to environmental pollution as it may contain harmful substances like heavy metal or residual chemical. Operational challenges are other significant risks as the process requires precise control of aeration and microbial activities. Any imbalance can reduce treatment efficiency or lead to excess sludge production. Moreover, the high energy consumption of aerosol tank makes the process cost, costly. raising concern about its sustainability, especially in produce in resource-limited area. Although problem during the decomposition of organic matter can also negatively impact the surrounding communities. Lastly, managing excess land is resource intensive, requiring proper infrastructure and planning to avoid logistically and environmental issues. Addressing this risk through substantial practical practice, monitoring system, and efficient planning, efficient management can ensure the active slab process remain both effective and environmentally responsibility.